Hello, myself Pradeep Kumar Sahu, and I've done my post graduation in applied mathematics from South Asian University, New Delhi. And after that, I have 3 years of experience in teaching class and 11th, 12 students. So in this lecture, we will learn a topic which is a part of application of derivative, and the topic is increasing and decreasing function. In daily life, we uses this concept in various scenarios. Like let us take an example of a car company. If a car company have to analyze its sale, then he plots the graph between the time period to the sales over the years, and if we can see the graph is increases, then we can conclude that the sales of the company increases. If the graph goes down, the sales of the company decreases. So these are the examples of uses of this concept. So in this lecture, we will learn about what is monotonic function, then second is interval of interval of finding interval of finding interval of increasing and decreasing, interval of increasing and decreasing of a function which we will find using the derivative concept. Then we will see some examples. Okay. Now, so what is monotonic function? So in general language, monotonous means monotonous monotonous means same behavior. But in mathematics, a function is called monotonic function if it is strictly increases or strictly decreases over its domain, then it is called monotonic function. Let us take an example of sin x. We can see that this is the graph of sin x. From 0 to 2 pi, you can see that from 0 to pi by 2 the function increases, and from pi by 2 to 3 pi by 2 function decreases. The graph goes down from pi by 2 to 3 pi by 2 and goes up from 0 to pi by 2. That means the sin x is not monotonic function on the domain 0 to 2 pi. But if I will restrict its domain from 0 to pi by 2, then it becomes monotonic function. Okay? So now, according to the definition of monotonic function, a monotonic function can be of two types. That means it can be strictly increasing or strictly decreasing. So let us take a function. I am taking a function f of x defined on an open interval ab. Okay. Then let I am taking two arbitrary elements from its domain ab. Then I can define the increasing and decreasing function, and decreasing function. Okay, this function f of x is said to be increasing if here let's take x1 is less than x2. If for this function f of x defined on open interval ab, and I am taking two arbitrary elements from its domain, and such that x1 is less than x2, then the function is the function is increasing. Then if f of x1 is less than or equal to f of x2, then similarly, okay, the function is decreasing if f of x1 is greater than or equal to f of x2. That means if we are increases the x values, then the functional value increases or remains steady, because there is an equality sign here. And in case of decreasing function, if we keep on increases the value of x, the functional value decreases or remains steady. So if f of x1 is less than or equal to f of x2, if I will remove the inequality sign, then it is called strictly increasing function. If f of x1 is equal to f of x2, then it is called monotonically increasing function. Similar case for the decreasing function. If f of x1 is greater than f of x2, then we call it as strictly decreasing function. If f of x1 is equal to f of x2, then we called it as monotonically increasing function. So this is the general definition of increasing function and decreasing function. Now let us link increasing function, decreasing function to the derivative. So I am writing a statement, let f of x defined on f of x is continuous on open bracket ab and differentiable on close bracket ab, then f of x is strictly increasing function if f dash x is greater than 0 for all x belongs to open interval ab, and f of x is strictly decreasing function if f dash x is less than 0 for all x belongs to ab. Let us prove this statement. So prove, first of all, let I am taking two arbitrary elements x1 and x2 belongs to ab such that x1 is less than x2. So since this function is continuous in open interval ab and differentiable on open interval differentiable on closed interval ab, so we can apply mean value theorem. Okay, so according to the mean value theorem, I will have a point c belongs to x1 comma x2. Since I am taking these two arbitrary elements, so if c belongs to a to b, then c also belongs to this x1 and x2. Now c belongs to x1 and x2 such that f dash c is equal to f of x2 minus f of x1 by x2 minus x1. Okay, so from this I am getting x2 minus x1 f dash c is equal to f of x2 minus f of x1. So this is always positive because I am taking x1 is less than x2. So if this becomes positive, then this becomes positive. If this becomes negative, then this becomes negative. That means if f of x2 minus f of x1 becomes positive, what it implies? Then it implies that f of x2 is greater than f of x1. That means strictly increasing. If it is negative, then f of x2 is less than f of x1 because it becomes strictly decreasing function. That means the a functions is increasing or decreasing, it depends upon its derivative. If it depends upon the sign of its derivative in its domain. Okay, now if I will observe it from graphically, I can observe it from graphically also. Increasing graph, I am taking increasing graph and decreasing graph. So from increasing and decreasing graph, now I am taking decreasing graphs. So in this case, these three are increasing graphs and these three are decreasing graphs. So if I will draw a tangent here, then this theta, the angle between the tangent and the positive deviation of x-axis is less than 90 degree. That means tan theta is greater than 0. So tan theta represents the slope of this tangent, which is dy by dx is greater than 0. Okay, that means in case of the increasing graph, the derivative is positive. So in case this is theta, which is also an acute angle. That means dy by dx is greater than 0. In this case, this also the theta is acute angle. That means the dy by dx is greater than 0. But in case of decreasing graph, you can see that this theta is an obtuse angle. That means theta is greater than 90. That means tan theta is tan theta is less than 0. That means the dy by dx is less than 0. So in this case also, this is obtuse angle. So this is also for the same case, dy by dx is less than 0. In this case also, this is theta is an obtuse angle, the dy by dx is less than 0. So you can observe that in increasing graph, the derivative is positive. In case of decreasing graph, the derivative is negative. But we can have a function. You can have a function. We can have a function which can be simultaneously increasing in its subinterval of its domain and also decreases in its another subinterval of its domain. Then what we will do in that case, the point of the critical point concept rises from this concept. If I am taking a function, the graph of function, you can see that from A to C the graph increases and from C to B the graph decreases. Okay, that means from A to C the derivative is positive, and from B to C, so from C to B the derivative is negative. So in the point C, at the point C, the graph changes its nature from increasing to decreasing. So this point is called the critical point. This point is called the critical point where the derivative becomes 0. The derivative vanishes. If I will draw a tangent here, then here dy by dx is equal to 0 because it is parallel to x-axis. So what is critical point? The critical point is defined as if the derivative is equal to 0 or the derivative is not defined, then we call it as critical point, or in words, a critical point is a point where the function changes its nature from decreasing to increasing or increasing to decreasing. For not defined case, you can take an example of mod x. Here you can see that at 0 the function changes its nature decreasing to increasing, but here the derivative is not defined. In some cases we can see that the nature of monotonicity does not change here. Okay, since at 0 the function does not change its nature, it goes on increasing. After 0 it also goes on increases, and in this case this point is called inflection point. It's called inflection point. Now what is the process of finding interval of increasing and decreasing is that, what is the process of finding? Now first find f(x), okay, then put f(x) is equal to 0 to find critical points. Let C1, C2 and C3 are my critical points. Then we have to draw a number line including the domain. So C1, locate the critical point C1, C2 and C3. So you have to check for the every subinterval. Let's take a point here, then put the point in this first derivative of f of x. If it's positive, then the function is increasing in this interval. If it is negative, then the function is decreasing on this interval. Then we have to do the same thing for these remaining intervals, so we can find the interval of increasing or decreasing. Okay, now let us take an example to understand this concept. I am taking f of x is equal to x cube minus 3x square minus 9x, okay, plus 6. Okay, so first I have to find the derivative. This is 3x square minus 6x minus 9. So okay, now I have to put f(x) is equal to 0. Now if I will put f(x) is equal to 0, it becomes 3x square minus 6x minus 9 equal to 0. It becomes x square 3x square, 6x, 3x square minus 6x. If I will take 3 common, then it becomes 3x square, it becomes 3x square minus 6x minus 9 equal to 0. Minus 9 equal to 0. Then it becomes x square minus 2x minus 3 is equal to 0. Now if I will factorize it, it becomes x minus 3 and x plus 1 equal to 0. That means I am getting x is equal to 3 or minus 1. So these two are my critical points. Now I have to draw a number line. this is -1 and this is 3. Now I have to check for these three sub intervals. Now if I will take a point between 3 to infinite, then the f dash x becomes positive, and if I will take from -1 to 3 a point, if you will put a point in between -1 to 3 here, this becomes what? Negative, and this becomes positive. That means it becomes negative. And if I will put a point -infinity to -1 here, then it becomes negative, and it also becomes negative, then it becomes positive. Then the function is strictly increasing from the interval -infinity to -1 union 3 to infinite, and strictly decreasing from the interval -1 to 3. Okay, in this case, in this way we can find. So now we can use a trick here to find the without putting the point here, using the wavy curve method. What is the wavy curve method? The wavy curve method is applied for if the function is only polynomial, and if the function is in case of polynomial functions, and if I can factorize the f dash x in linear factors, then according to wavy curve method, without taking any point here, we can put the right hand side will be positive, and then you have to check the factor of 3, the power of factor of 3. Then if it is odd, then we will change the sign to minus, and you have to check either the factor of -1, which is x plus 1, the power is odd, then again we can change the sign here. So using wavy curve method, we can directly find the nature of its derivative. So tips: if f of x is a polynomial, and f dash x is equal to x minus alpha, and x minus beta, and x minus gamma, so on, then use wavy curve method to find nature sign of f dash x, to find the sign of f dash x, which we can find directly without putting the point. So in this lecture, what we have learned that the summary. What we have learned that a function is f of x is strictly increasing if f dash x is greater than 0, and if f of x is strictly decreasing if f dash x is less than 0. And we learned the concept of critical points, and how to find the interval of increasing and decreasing. Okay, thank you.